Testing 1, 2, 3. We all ready to roll? Two more minutes. All right, team, we'll get started in about 2 minutes. Thanks. All right, team, we're going to go ahead and kick this off. Thank you all for coming this afternoon. My name is Michael Wigand. I'm a former Army cyber officer, along with a bunch of y'all in uniform today. Thanks for coming. And now the Chief Growth Officer and co-founder of Shift 5. We're a company that defends planes, trains, tanks, and satellites from cyber attack. And I'm joined today by my partner.
Hey folks, Ray Cruciati here. I'm a senior systems engineer at Splunk. Definitely excited for today's presentation and look forward to potentially talking with you afterwards. Thank you.
And so today's talk, we're going to talk about unlocking data from weapon systems specifically. We're going to start off by covering some weapon system cyber issues, and then we're going to talk about the potentials to use the data that we can harness off our weapon systems for more than just the cyber use case, and talk about predictive maintenance and some really exciting experiments that have been conducted recently by the Army and the Air Force that showcase some of the fun things we can do. So a little bit of background. My life's work really is dedicated to this challenge statement. This is my mission right here. The problem that we have across DoD and I would say critical infrastructure verticals in the civilian market, but back to DoD, is that many of our weapon systems today have little or no protection from cyber attacks. So let's break this down. First, what do I consider a weapon system? So I'm a former Army guy. Weapon systems are tanks, Apaches, traditional stuff, right? They shoot, they move, and they communicate. And it turns out that weapon systems also are comprised of line replaceable units. These are embedded computers that are tied together using internal data networks in order to make them function. And it's these internal networks and the automation under the hood that gives our weapon systems the lethality and tactical capabilities that we might take for granted today, because tremendous advances have been made over the decades to get us the platforms that we use today to project kinetic combat power. So weapon systems today, right, have all of this key cyber terrain under the hood, but it's not a common topic at conferences like this. There is not a wide variety of products, and certainly there is nothing deployed into operational fleets today that enable us to apply a lot of the principles from the cyber risk management framework from NIST or other cyber defensive principles on our weapons platform. So let's break that down a little bit. What are we missing on our weapon systems today or on civilian critical infrastructure? On the right here, we see 4 subtopics. When I break this problem down, I think first and foremost, we don't have the ability on many of our internal weapon system data buses to monitor them continuously. Now, why is that? Well, most of them are not operating TCP/IP networks. We're talking totally bespoke serial data bus architectures. If anybody has ever heard of the MIL standard 1553 data bus, put your hand up. And this is a technical audience, so I expect to see a couple come up, but still a minority of the audience has heard of that. The 1553 data bus, which our company is actually named after, is the data bus that allows everything from the International Space Station to the F-16 to the Abrams tank to operate. It's the highly redundant, bulletproof, nuclear, rad-hard communications infrastructure that allows all of those, ultra-rugged embedded computers to communicate and enables all that subsystem functionality. Today, our cyber protection teams and Air Force mission defense teams across all the services, we can't just plug into one of those and collect data, so we can't monitor them. Observability is a problem. Number 2, we have a lot of different LRUs and embedded computers. They're running code. Some of that code is software, some of that code is firmware. Today, on most of those systems, we cannot cryptographically verify or cryptographically secure the update processes for that code. So if any of you have spent time in a motor pool, right, you go to Fort Hood Monday morning, we're going to have thousands of soldiers doing formation, and then they're going to do their PMCS on our weapon systems. And some of those soldiers are going to be our wheel and track mechanics, and they're going to have maintenance devices and data loaders. And they're going to take those devices, they're going to jack them into weapon systems, and those weapon systems are going to communicate back fault codes, just like you get off your CAN bus when you take your car to Jiffy Lube and they triage your engine control unit, right? But also, these devices can be used to update the code and the firmware, the functionality on the weapon systems. Now, this code goes through a complicated safety evaluation and release process that's managed by the program managers, but it's not secured all the way down to the last mile on most weapon systems. So that's a major problem. We have some supply chain vulnerability there. And by the way, none of this is specific to weapon systems, right? I mentioned everything that applies today. We can talk commercial aviation, same problems. Commercial rail, diesel electric locomotives, same problems. Off-road mining, oil, gas equipment, same issues. A lot of common commercial off-the-shelf components we find in both the civilian and DoD markets, right? And then third, we can't alert crew and maintenance personnel to cyber anomalies today. Where's my cyber check engine light on my car? Doesn't have it, right? But we all know our modern cars are, they're all fly-by-wire essentially, right? There is no cable anymore from your brake pedal to your brake calipers. It's an electrical digital message that goes to a series of different computers that causes your car to brake today. Unless you're somebody that's a motorhead and you have an antique vehicle, right? But anything you pull off the lot is essentially going to be fly-by-wire from acceleration and braking perspective. We have the same issue on all of our ground, air, sea weapons platforms, but no indication, alert, or warning to our crews. As a former Bradley commander, that's disconcerting to me because I'm smart and I know how to operate my weapon system in degraded modes. I just need to know when and what subsystems I can or cannot trust, right? And then finally, we don't have full take data capture or system access logs to enable our teams, especially our cyber folks, to go back and figure out what happened when we suspect something is amiss, right? So we get some indication, some alert warning because there's some type of monitoring system. Who's going to come save us, right? Who is going to deploy out into the field in order to provide some service support to that armor brigade combat team or to that aviation regiment that's providing operational support, capability to the field commander. Well, today we haven't appropriately enabled, from a materiel perspective and from a training perspective, our responsive teams to get all of this data, and we don't have full take data capture that's going to let them go back in history and figure out the 5 W's plus the so what to that commander. How did the malware get in, right? What was that access vector? Where is it persistent? How did it traverse the internal network? What were the effects and how did they manifest themselves, right? We can't answer these questions, and the best we can do is look at crash hard data recorders on aviation assets. But what were those designed for? Crash analysis. They are not full take frame or packet data recorders. So it's a really challenging proposition today to a cyber analyst who is given a weapon system, even if we're certain that it was hacked, to figure out what happened, especially if that implant or that effect burned off. So this is the DoD challenge before us, and like I said, this is not unique to the defense world. This is also completely applicable to all of our critical infrastructure verticals as well. Now, this is a new problem. So DoD has been studying this and looking at it since at least 2015 in earnest, right? In 2016, the NDAA that year had provisions for the 1647 Cyber Resiliency of Weapon Systems Assessments. And it said, hey, services, listen up. Congress is saying we need to do these weapon systems cyber vulnerability assessments. Come back in 3 years, tell us how big the problem is so we can prioritize funding and support to get after the issue. GAO report came out in 2018 summarizing this. Fantastic read, definitely look into it. The highlights, though, are these bullets down here, that this is a problem and that the problem is only going to continue to accrue risk because of these trends, the computerized nature of weapon systems. Nobody thinks that our weapon systems are going to get dumber or more analog as we move forward, right? Number 2, late start in prioritizing cyber requirements and tying them to the system survivability key performance parameter in the JSIDs and requirements process. What does that mean? Well, when we look at a requirement that enables a new weapon system, clean sheet design, right? Optionally manned fighting vehicle replacement for the Bradley as an example. 20 years ago, we weren't thinking about cyber requirements. So that meant that our OEMs, our integrators, and our program managers didn't have the framework, the funding, the way to communicate the need to solve those problems on that earlier slide, right? Well, we have that today for new systems, and we have structures to fix that for legacy platforms. But then finally, why is this a studied and known problem? And this is going to be a real world of our lives? Well, look at our adversaries, top 4, top 5 nation-state adversaries. They rely on asymmetric and hybrid warfare techniques to level the battlefield playing field because they can't fight in a toe-to-toe, above-board fight against us, right? Our defense budgets blow everybody else away. Our technology's more superior. So what do they need to do? They have to buy time by degrading and denying our kinetic capabilities, our ability to move forces into theater, right? This is A2AD on a cyber perspective, preventing 7th Fleet from getting into position, right? Preventing 2nd CR from doing their RSOI activities and actually getting up to the engagement area, right? They are going to leverage what I argue are, advantageous capabilities from a dollars perspective to try and level that playing field. They're going to play dirty. Asymmetric hybrid capabilities. This is straight out of our adversary's playbook, and we need to be talking about this and figuring out how to get ahead of it. Again, known studied problem. So let's talk about access vectors and how our weapon systems are vulnerable and what the effects can actually look like. And again, this is an unclassified presentation, but we just want to cover the basics. So 2 types of classes that we break down cyber access. On net, everybody's super familiar with that, right? You connect to the internet, series of networks enables you to interact on the data layer with some type of computing device somewhere in the world. This is generally where the cyber conversation for weapon systems has traditionally started and ended, right? We've conducted ATO assessments on weapon systems platforms. We've attempted to apply RMF to our weapon systems. But if there wasn't a network connection, there wasn't an RF connection, whatever, then we said, well, it's air gap, nobody can get to it. And I'm telling you that is, in 2021 and moving forward, that is a false security blanket that we need to acknowledge. Some of our supply chain cyber vulnerabilities against vendors that are here, right, that have been published, I won't name names, but that brings to attention these off-net access vectors that are real, that we really need to address. So what do those look like? And what is the most likely access vector from an advanced persistent threat? It's going to be these three things here: maintenance activities, witting and unwitting, uniformed personnel conducting authorized procedures being used as access vectors to pivot malware onto our platforms. What do I mean? It's going to be that mechanic, again, right, at Fort Hood, who's doing what he needs to do, but doesn't realize that by going down that motor pool line and plugging in his data loader, he thinks he's just pulling data off and doing his authorized activities, but he doesn't realize that his box is being used as the pivot point in order to get malware onto that platform. That's a real issue, a real problem that today is unaddressed on many of our platforms. 2, supply chain access, right? Where do our repair parts come from? Where are they manufactured? How are they transported to the SSA? Can people get their hands on them? Can they change the malware, firmware, even add hardware implants to this? This is sensitive and scary stuff, but again, if we're not securing all of the subcomponents and every aspect of the compute and data that ends up getting integrated into the weapon system, from a life cycle perspective, we're accruing risk. And then finally, physical access during movements. So anybody that's deployed armor overseas is generally aware that we have SOFA agreements with our allies, which means that our equipment is going to have hands-on with uncleared foreign nationals. All right, and I'm not saying that we can't trust those folks, but we can't trust those folks. All right, this is a real thing. People can get hands-on our gear. Physical security of our weapon systems is a real issue, and we should not take that for granted. Even when we deploy guys to escort our rail movements to ports, to sit on the boats, those rows to take them overseas, I'm telling you there are ample opportunities for foreign actors to get physical access with our system. So these are, off-net is actually the most likely access vector, and from a lot of our commercial engagements, we believe that this is substantially under-recognized in both the commercial and the federal market. And it represents, believe it or not, I think a lower risk, higher likelihood of mission success opportunity to an adversary that wants to compromise our system. So we have to take this stuff seriously. So what's the solution? How do we solve this? And this is not a sales pitch today, right? But looking at this from a requirements perspective, I argue that what the conversation we need to have is that we need to enable our crews, our maintainers, our commanders, and our cyber protection teams in order to have observability of the key cyber terrain within their weapon system. Our crews are smart. They're well-trained, right? We put tank crews through hundreds of hours of simulator training. Then we take them through all of these tables, right? All of this field training, and we do this on a twice annual basis. So your average, tank commander who's a E6, right? I mean, he's been through that at least 4 or 6 iterations. He knows his weapon system inside and out, right? We need to respect that, and we need to empower our service members to give them some insight into the cyber efficacy, give them some feedback from this weapon system so that they can judge for themselves how much confidence they should place in some of the different subsystems, right? Can I trust my communications infrastructure? Can I trust my mobility? Can I trust my weapon systems? There needs to be feedback from weapon systems today to air crews, to armor crews, whatever the case may be, letting them know if they can or cannot trust certain components, because we train for the contingency, right? We train to operate in degraded modes. So let's give some feedback to the crews so that they can do that. Our maintainers, there are things that maintainers can do if they can identify that, hey, there is an actual cyber anomaly here. This isn't a maintenance anomaly, right? There are things that we can do in order to try and recover systems, put them back online as quickly as possible. But again, we have to respect the ability for our maintainers at the 10 all the way up through 40 level and our FSRs, together with feedback, we can empower them to help fight through and make systems available in some type of cyber tech. Let's give them that insight, give them that observability. Commanders, boy, we need to understand what our cyber risk, cyber readiness looks like on our weapon systems. I'll just leave that there. I don't think that needs to be belabored. But then our cyber protection teams, we have a bunch of reps in the room from MDTs and CPTs. They need the ability to walk up to a weapon system in an incident response mission and be able to pull data off and answer 5Ws. Is the system compromised or is it good? If it was compromised, how did it happen? How do we prevent this from spreading to the rest of the fleet, right? How about active hunt, getting ahead of the threat? Hey, a COCOM commander says, I care very much about these two systems right here. I would like to use my cyber protection assets, pre-position them on these particular weapon systems to survey fleets and be able to enforce confidence that they're going to be ready and available for a specific mission, right? We need to be able to enable all of that. So it's all of these things on the right? Give configuration management and control, configuration sensing of LRUs, enable this. This solves a lot of PM problems too, makes a program manager happy. Detect those access vectors, right? Detect and classify the different anomalous capabilities so that we can troubleshoot the problem, alert the crew, provide real-time data capture at the frame level, and then translate that data and make it available to our analysts. We have really, really smart people. Let's get ahead of the problem by instrumenting our systems. So I'd like to hand off to Ray really quick to talk to us about data, and then we'll start a discussion on the data potential beyond just cyber.
Thanks, Mike. Appreciate it. So, going on with what Mike was saying, the observability and being able to analyze a lot of this data, this very important data that he's outlined already, you need to have a platform that's very scalable. When you look at, a lot of folks today, they're working with data lakes that have, back-end relational databases where they're having to go through and structure a lot of this information before they could really extract value out of it. You have lots of weapon system data that you could potentially be feeding in for analysis. And when you look at this serial bus data, like I said before, you need a very scalable platform to do that. A platform that can maybe bring in terabytes, petabytes of information as you could kind of pivot through it in real time and extract a lot of value out of it. Being able to point in any source of that information into an analytics platform, to be able to do schema fly, schema read, being able to do those extractions, visualize a lot of it, and those capabilities are things that customers are really looking for today. And looking at the raw events, so there's a lot of important information that's in this data that we're feeding in. So being able to look at the raw data and being able to do real deep dive analytics on all that information, maybe being able to run that data through machine learning algorithms to see where there are statistical and numerical type outliers, where something looks out of the norm or odd, whether it's a cyber threat, whether it's a maintenance issue. And we're going to touch on a couple of those different use cases here in a second. As Mike said before, not really trying to sell a product, but the integrations between Shift5 and Splunk, we give you the capabilities to do a lot of that. And a lot of the use cases are outlined on this particular slide right here. From a cyber standpoint, going out, the CPT teams going out and doing incident response, going out and doing things like threat hunting. They need a tool that's very flexible that you can go through and pivot through all of that data to look for a lot of those type of anomalies or threats. So you could go in and remediate those threats, as they've been detected. And another thing that we want to look at is doing like predictive maintenance. So a lot of valuable information coming off of, as Mike had mentioned, planes, trains, tanks, any sort of device that's generating this type of information. You can go out and see where there's particular component wear on that ground vehicle, where it needs to actually be serviced and maintained before it's out in action again. Lots of valuable information that you could extract from that as well. And that's really what I wanted to cover in this slide. Go ahead and hand it back over to Mike.
So, the big takeaway is that solving a lot of our cyber resiliency requirements on weapon systems was projected to cost us a fortune. But what we've learned through some use cases recently with the Army and the Air Force on ground combat vehicles and air platforms is that it doesn't need to cost a fortune, that the data that we can harvest off our platforms and put into an analytic tool like we've demonstrated on some use cases with Splunk can be operationalized and save program dollars, offsetting the cost of all of the hardware, software, and integrations that enable the resiliency. So boiling that down, we can add cyber resiliency into weapon systems cost neutral by saving dollars in predictive maintenance and increasing our cyber risk posture or cyber survivability posture on our platforms. That is a huge, huge takeaway. So some recent integrations that we've done with Splunk in the service of that have actually been with the Air Force and the Army, like I mentioned. We have a project ongoing with PM Stryker right now through Army RICTO. We really want to thank Army RICTO for supporting us and selecting us as an Army Innovation Day winner. The effort was to demonstrate a real-time, persistent IDS that did full take packet capture on a Stryker combat vehicle and enabled a cyber protection team to do all of their individual and collective tasks on that weapon system. And just recently, we conducted a successful software integration lab and vehicle demonstration of that. Using Army Red Team assets, emulating a Red Team, they threw different attacks against the system. Our team, the defensive tool, had an opportunity to train against some of those. So there was a blind test and then a test to show how quickly rules could be written. And the results are in. We were able to detect most of the attacks and do so near instantaneously, providing that feedback. Further work that's still to come is actually providing an integration into the Stryker Commander's display that allows them to get some feedback and understand what systems are degraded, to be able to click a button to have a clean, known good configuration reloaded into a specific LRU so that you can attempt to self-heal or recover on the fly without having to wait for maintenance to get out there, or swap a box out, which you're going to exhaust your supplies if that happens on a fleet-wide level. Additionally, with the Air Force recently, we did a really exciting integration with Splunk in support of the Air Force Special Operations Command, where they had a manned aircraft that has a really unique mission. It's a cargo plane. We integrated hardware and software that was doing data collection, providing real-time IDS. If a data connection, a satellite connection existed, we could beam that data off the vehicle so that you could have a cyber protection team monitoring this no matter where it was in the world, as long as there was a data link. But otherwise, it worked RF dark. And what was exciting was that for the first time in that program's history, we were able to pull back all this data that before we could even demonstrate the cyber use case was already showing benefits with the predictive maintenance. Actually, there was a dip in message flow volume that was noticed by one of our analysts that was just triaging data from a data pool after some flight tests. And we were like, well, that's really strange. Let's look into it. Using the power of Splunk's tool, we were able to get in there. We were labeling all the data. Everything is human-readable, exactly like what you would expect from Wireshark or like a Bro or Zeek-like solution. And we found that there was an LRU, a specific navigation computer, that kept falling over and power cycling. But very strangely, there was no indication to the aircrew that anything was off. We determined in further investigation, working with the program manager and the FSR and the OEM, that there wasn't any type of cyber anomaly, but this was a really exciting day for the maintenance team because they never got a report or an indication. And now they're able to monitor those boxes across their other air assets and figure out if this is a trend or if that was something specific to that box. We are just starting to scratch the surface on these other data use cases because to our knowledge today, there are not many weapon systems driving, flying, or sailing today that are providing that full take packet collection, data acquisition capability back. That's why program managers can't conduct any type of automated configuration pull, right? What are all of the different LRUs that I have on my weapon systems and what are their software firmware systems? We've been using Alarac messages in the Army and sending guys out to go read stickers and fill out Excel charts for years to try and get after that problem. What if we could do that with some technology, automate that process, and go a layer deeper? So, with that, those are two vignettes or use cases of, exciting examples that we can get ahead of this problem. We can solve this. I'd love to answer any questions from the audience, and please come seek us out afterwards. We want to start this conversation at AFCEA and with the community and advance the state of our cyber resiliency on weapon systems. Thanks. All right, here's my first question. Right here. Let me pass the mic to you, sir.
Yeah, thanks. Captain Nick Stark, Army Cyber Institute. So I was curious how extensible this process is. Are you building kind of unique solutions per platform, or is there kind of crossover or use from one development to the next?
So I don't want to make this a sales pitch or about our product, but I'll answer this from the perspective of what the military needs from a requirements perspective. Is that okay? And then we can talk specific product stuff later. But the military needs, all of the services need a single, common, open architecture solution that can be rapidly applied to different weapon systems and then feeds a common backend that is already congruent with the types of tools and training that our folks have, right? So let me expand on that just a little bit. All of our weapon systems need some type of full-take data capture solution that resides on the platform. They also need the ability to do some intrusion detection, some alerting. That intrusion detection needs to have some rule sets that are based on the specific underlying protocols, but can be extended by our cyber warriors, can be extended by program managers or other contractors. So, anybody should be able to contribute to a new detection algorithm or signature. Those algorithms and signatures, by the way, can and I think need to be both static, meaning like traditional whitelist, blacklist rules, but we also need to be able to run dynamic algorithms so that as we, the service, accumulate larger data sets, we should be able to train models that look for anomalies and tell us what we think is going on. We should be able to apply that cutting edge, sorry for the buzzwords, but AI techniques in order to do anomaly detection and classification. So that's fundamentally what I believe is needed. It's going to take a community, and the tool needs to be extensible and evolve so we can stay abreast of and ahead of the adversary's TTPs. Because if you just put something out there and a cyber protection team can't make it smarter, it's not constantly being invested in, then it's going to get stale very quickly, and I think we will have made a poor investment. Ray, do you want to expand on that? Okay. Awesome. Fantastic question, sir. Thank you. All right, who else? Sir?
Hi, Rob Frost. I'm a cyber officer. So also once upon a time in an Armor unit, and I think back to trying to stream FBCB2 data, and you couldn't even get that all the way to load with your network. How data intensive is it going to be pulling data and streaming it back off of one of these bus networks, and how do you prioritize?
Thanks, sir. Appreciate the question. So I believe very strongly that any solution that a service invests in has to be able to operate in a contested EW and cyber environment, right? So what does that mean? Well, there's probably going to be extensive jamming where you're not going to have an RF link when you really need this thing to work. So you need to be able to operate in an online, connected, hybrid, and disconnected mode. What that means is that in a wartime scenario, the default functionality of a solution is that some type of cyber protection team needs to be able to physically go to an asset, jack in with a cable, and pull data off, and be able to do their incident response and analytic capabilities on the edge and quickly. Now, in order to address the bandwidth concern, any type of solution needs to have really high data compression and not impose a massive bandwidth requirement on existing networks, because Lord knows that is a tough problem. Anybody that's worked in a signal unit knows that bandwidth demand will always exceed the capacity. So what we've demonstrated recently for streaming applications is actually getting really, really high compression on the data that's being collected, higher than what's possible today monitoring TCP/IP networks. And the reason for that is because fortunately our weapon system networks, these operational technology networks, they have very regular data. So you can train compression dictionaries and compression algorithms to get in these incredible compression ratios that you normally would never get on a traditional IT network. To put some numbers to this, off of an unmanned platform that we may be working on, looking at a 1553, A-Ring 429, and a couple RS 422 data feeds, we're able to pull 100% frame capture back over a sat link, along with metadata and alert data streams in under, I think it's a 1/4 megabit per second at kind of full rate. And then we've demonstrated the ability to subscribe to smaller data feeds so that we are only soaking up basically discretionary bandwidth, if you will. Mission bandwidth always comes first. So those are some thoughts to requirements developers and an example of best practices and where I think the technology is today, state of the art. Thank you, sir. Did that answer your question? Awesome. Now, interesting bandwidth question. So when it gets to a solution like Splunk, what we do is we uncompress and then load all of that data in. And Ray, could you talk about how some of the Splunk deployment use cases?
Sure. Yeah, so outlining disconnected networks, being able to have the flexibility of taking data and dumping it into the platform and being able to do real-time analytics on that information, which a lot of cyber protection teams do today already. But when you look at connected networks, from bandwidth limitations, security type concerns, being able to encrypt data in motion as it's making its way into the platform, making sure you have the capability to do that, and from a bandwidth concern, being able to fine tune the platform, making sure you're architecting the solution correctly to receive that data. In real-time fashion, as fast a real-time fashion as you could get. That's a very important and valid concern for a lot of our customer base in the DoD today.
Thanks, Ray. All right, 2 fantastic questions. Can anybody follow that up with a better one? What do we got? Technical, operational? Anybody? Is there anything for us? Okay, one over here. Would you mind introducing yourself first?
Yeah. I'm Matt Utley. I'm the MI Battalion Commander for 1st Special Forces Command, so we do intel support to information warfare. Maybe not a better question, but the requirements that you just laid out are fantastic. How do you keep them from pricing you out of the market and not being able to get started? So how do you kind of cut the cost back? You mentioned offsetting with preventative maintenance. What are some of the other strategies you have to keep it affordable?
So some ideas for operational commanders and for folks that it can influence requirements or who own weapon systems. One, there are pots of money in the Army and in the other services that can be used to do cyber vulnerability assessments on your platforms and can be used to buy prototype solutions. When those prototype solutions pan out, you can go get POM dollars, and the money is there from Congress to increase cyber resiliency of weapon systems. We have specific tips and tricks that we can offer to you all on how to engage with the Joint Staff J6, the ASALT office, and other stakeholders that have those requirements and are searching for operational folks with need, both in the operational community and in the program community. What we have done is we've demonstrated time and again for single-digit, 7-figure budgets and uncompressed timelines to be able to show up, conduct a complete cyber survivability risk assessment and cyber endorsement memo for a weapon system owner and go all the way to red team demonstration, training exercise, defensive solution integration, proof, all within under 12 months on weapon systems, and do that very efficiently and at low dollar cost. The name of the game is not to belabor the problem. I think that TSMO, ARL, SLAD, and other red teams across the military have made it abundantly clear that our weapon systems can be hacked and what the effects can be. And then at the secret and TS level, what the operational and con plan implications are. We're not here to talk anymore or belabor the problem. This is about solutions. And the good news is that there are ready solutions out there that have been proven. The TRL level or technology readiness levels are there, and they're just and the whole effort is accelerating. So we'd love to follow up with you and link you up with some of those government contacts later. But the good news is that it can be done, is being done, and would love to link you up with those that have that expertise. Thank you. All right, we got a question in the back. Let me walk this back to you.
Hi, Daniel. I'm from Boeing. I've got a question about offline versus online. Does it, as he brought up, does it vary with your cost? And other than real-time data, what benefits do you see from online versus offline, say, for instance, in a plane?
Thank you, Daniel. So offline cost and ConOp benefits. Did I get that right? So actually, let me first pass this to Ray. Because there are a couple different cost components. We have our own product and model, and then we partner with SIEM providers. We've been super impressed with the stability and maturity of the Splunk platform. That's why we're here talking together. So could you talk to those?
Yeah, so great questions. There's a common misconception when it comes to Splunk that there's just one licensing model. It's a daily ingest licensing model. That's evolved over the years. There are several other licensing models. For cyber protection teams, there's a flat kit-based licensing model. We do know that ingest varies from day to day. The missions that cyber protection teams are going out and supporting, where we want to give them the ability to load as much data in as they're performing an investigation. And that was really the whole reason behind coming up with that kit-based licensing model. Outside of that as well, the traditional ingest licensing model, we came up with a Vcpu licensing model where it's based off of how you're searching through that data. So, we really want to give customers the flexibility, if they're bringing in a lot of data, a lot of their saved searches and visualizations and dashboards that they set up, only licensing on what they're searching for at that given point in time. So there are different licensing methods, and it really all depends on how you're going to leverage the platform.
Now, from our perspective, so equipping the weapon system, we have to install typically a host that's going to, host the onboard software that's going to do the data acquisition in the IDS. That software is typically sold at cost, and so you have a per instance basis. So you're going to upfit a brigade of strikers. There's going to be X striker times that equipment cost, and that's typically going to be in the tens of thousands, low tens of thousands of dollars, not including install labor integration. And then for us, we have a very simple licensing model. We support product updates, rule updates, and provide product support on a per instance annual license model. The thing is that the product needs to continue to evolve, and so we have an entire company that builds new features, that is on the cutting edge of weapon system attack research. We do that at the classified level, at the unclassified level with our commercial partners as well. And so that license enables all of those feature updates to be continually rolled out on a quarterly basis as software updates and signature updates. So that's how we operate and help sustain the effort. If I might toot our horn, I think we're the only company that exclusively focuses on securing weapon systems in the U.S., but we're also not a defense contractor because we focus a lot of our energy on the commercial markets. Now, to the use cases, offline versus online, what I can say is that a connected system enables you to separate physically your defensive assets, right? Your cyber protection team or your MDT. You can physically separate them from where your actual weapon systems are located. So there are some advantages there. But if your weapon systems need to go RF dark, right? You're doing some type of clandestine operation you can't emit, or you're operating in a contested environment. That's why we have operational units, like some of these soft forces with cyber capabilities, like the 915th, our cyber support to core and below efforts. They have the requisite training to go forward into a contested environment and provide, OCO or DECO support at the edge. So I just firmly believe that a solution needs to be able to support both models because we just can't predict what future conflict will look like. And in medium and in high intensity conflict, we always need to design to the most restrictive or austere network conditions. Thank you, sir. All right, any further questions? One in the back, okay.
So, John Rollinson, Army Cyber Institute. When we look at something like a weapons platform, you're talking about a network that's far less diverse than, say, the internet. How do we ensure that sensors like what you guys are building can see anomalies that attack either the logical layer or the physical layer itself, and we're recording that data when it doesn't form nicely formed packets?
Thanks, sir. Appreciate the question. So on weapon systems, let me see if I can read back the question correctly to make sure I understood you right. Captain Rollinson, you said how do we detect cyber? Here, let's have a conversation. I think I misunderstood your question. How do we detect cyber anomalies?
Right, you're talking about a closed network with very few devices that have individual quirks that you can count on those quirks being there. How do we ensure like a device that you guys are building is reporting back the logical layer data, but still capturing things that may be happening outside of it?
Gotcha. Okay, so I'm going to talk about false detects on weapon systems. So when a weapon system designer, an integrator, right, a big defense integrator, makes a weapon system, it's actually not pretty at the IPT level, that integrated program team level. They have to take all of these disparate systems from, in some cases, dozens, in some of the more complicated weapon systems, hundreds of different vendors, and get them all to talk together. And sometimes they have to break rules, right? So I mentioned that MIL standard 1553 data bus. That was a DoD designed communication standard. And we have never gone to a weapon system where the MIL standard 1553 data bus was integrated to standard. There have always been quirks. So just like I think any network, you put an IDS solution on, that IDS has to be tuned to the network. And the good news is that on weapon systems, that tuning actually can get really, really, really tight. And what I mean by that is that you can knock out or create exceptions for all of the unique sins that those designers kind of put in at the data or the logical layer so that we don't trip on that. But false detects are the evil of this technology and are a conversation that every military commander and weapon system designer or requirements person needs to be focused on when they're evaluating technologies. But I would say that you can't just say, hey, we need a 0% false detect, out of the gate, because no technology works that way. You got to put it in, and then where you need to evaluate a vendor is their ability to quickly tune the system, get to a level of false detect ratio that's acceptable. Maybe you only have one false detect every 100,000 or million operating hours, something like that, right? But then what I think you care about as a uniformed person or a military person is how fast can the system evolve to new configurations, to new upgrades or mods? How fast can the system and the team, respond to these curveballs because they're all gonna come. We spend an enormous amount of time tuning our systems to be compliant with like new pods that somebody could roll out behind some green door and slap on a weapon system, and our thing has never seen it before, and we don't want it to go berserk. How do we handle that? But how do we still detect cyber anomalies? And I'm going to be honest, I don't think that we have that figured out. I don't think anybody else does. That is literally at the bleeding edge of weapon system IDS technologies. And it is a hard problem because basically you're asking to foresee things that you've never seen before and tell the difference between good and bad. And so I just want to be honest that is a really tough problem, but that is a central component, I think, to the conversation of making this work, fielding it, sustaining it. Ray, do you want to talk about maybe how, honestly, we dog feed our solution, which means we actually use the Splunk platform in order to detect and triage some of those anomalies and help us write our own rules for this use case. Could you speak about that?
Sure. So the great thing about the Splunk platform when it comes to situations like that is, the ability to quickly aggregate all this disparate data together. You may have lookup files, inside of Splunk where you can do correlation searches against information that's being fed into our platform to show where, potential risks are found. There's alerting-based mechanisms that are built into the platform where you can, automatically take some sort of action based off of, some sort of threat or something bad that is found to, maybe go out and call a script to do something very specific, a very specific action. So, there's lots of great capabilities in the platform to address situations like that.
All right, team, we have time for one more question. Who can close us out today? Last call. I know there are a couple burning questions out there. Don't be shy. Anybody in the back? Okay, all right. Oh, we have one more. Hang on. Where can we? All right, so we'll be so booth 701. Please come visit us. Also, Heather in the back, who is raising her hands. She can lead the travel party down there. Team, we'd love to engage with you guys. Bottom line is my ask, especially to our cyber and signal warriors here, is please take this conversation back. Program managers are starting to look at this because the JSID's manual has been edited and updated to force a cyber requirements discussion in our weapon system acquisition process. But what's missing is the warfighter saying, hey, we need and we deserve some feedback on cyber resiliency, cyber survivability, cyber confidence in our weapon systems. There are debates right now about if an aircrew needs to be informed or not informed about a cyber anomaly. And as a private pilot, that makes me a little bit upset. I want to know if I can trust my equipment or not. And I would like a system that could be extensible by the uniformed and contractor community to provide that feedback to me. But that's just my opinion. If you agree with me, please share those thoughts and insights with your chains of command, with your circles. Please help us with this conversation because at the end of the day, nobody is coming to save us. So team, thank you. It was an honor today, and I look forward to the further conversation.
I think this belongs here.
Oh, yeah, that looks like it does belong.
Yeah.
I'll ask another place, but I think you're right.
Hi, how are you?